For 36 years, Andrew Sykes has walked process plants solving seal problems. In that time, one myth has proven harder to break than any piece of equipment: the idea that seal failure is an unavoidable reality of industrial maintenance. You see the pattern in facilities everywhere. A joint springs a leak, it goes onto the maintenance list, and the plant gears up for a shutdown that arrives every 6 months like clockwork. Then comes the paperwork. A purchase order is raised automatically, requesting the exact same material that just failed to replace the broken seal. Nobody pauses to question the choice. The team simply installs the new ring, waiting for the subsequent failure, because that's the way it has always been done. But engineering science tells a different story. The fault rarely lies with the wrench turning of the maintenance crew on the floor. It points to a blind spot built into the underlying system. Treating a recurring failure as a routine scheduling task is a trap. It keeps management focused on managing the calendar, completely blind to the physical root cause sitting right inside the pipe. These rapid replacements appear on spreadsheets as standard upkeep, but they disguise a steady, compounding drain on the operational budget. Relying on these unquestioned automatic reorders guarantees hardware breakage, which eventually forces a devastating, unplanned plant shutdown. These sudden halts jeopardize the facility's most critical high-pressure lines, forcing them into highly volatile, unsafe states. Unquestioned maintenance habits are active threats, masking a severe operational bleed as a normal cost of doing business. To find out what's actually happening, we have to move past the paperwork. You can tell almost everything about a plant's maintenance culture by the physical seal they pull out of a failed joint. This macro photograph shows a destroyed elastomer, an industrial rubber ring. It precisely records a forensic trail of exactly how the system failed it. This diagram illustrates thermal degradation. A hardened seal with cross-section cracks indicates exposure to temperatures far beyond its limits. Chemical incompatibility presents differently. Foreign molecules penetrate the outer face, causing the material to violently swell as it rejects the environment. These elastomers don't break at random. Every crack and swell is readable, scientific proof the material is mismatched to the system it's supposed to protect. But then there is the most revealing anomaly. Sometimes a seal is pulled out completely clean and physically intact, yet the joint still failed. An intact failure proves the physical environment didn't destroy the rubber. Instead, the material was the wrong specification for the system's operating pressure or mechanical application. Poor maintenance execution is rarely the root cause of these predictable leaks. The true culprit behind every 6-month shutdown is a flawed original specification decision, a decision made years ago that nobody bothered to revisit. This pulls the problem out of the technical polymer data and drops it directly onto the desks of plant leadership. It is a matter of cultural accountability. Understanding failure must be engineered into the original specification phase, rather than being switched on only after a blowout occurs. The sites that interrogate why their seals degrade are the same facilities that record fewer unplanned shutdowns and boast superior reliability records. Mediocre sites scramble to patch the broken joint. Elite sites pause the loop, investigate the forensic evidence, and correct the underlying specification. A plant's true reliability record is dictated by its leadership's willingness to challenge inherited material habits. We often assume that a facility's operational standards are forged during highly visible boardroom decisions, but real safety standards are built in small, unseen moments, like choosing to question the material choice of a simple rubber ring. Solving the smallest component is the ultimate test of a facility's culture. For 36 years, Andrew Sykes has been helping process plants pass that test. Are you overthinking a rubber ring? Probably not.